Today we're going to look at the last notes in Chapter 1 of the Discrete Math book. It's Section 1.9, which deals with different kinds of reasoning. Normally when I cover this in a regular class, what I'll do is have different people read aloud. That's not really possible when we're doing stuff online though. So first off, I have scanned this section of the book and it'll be available to you in Google Classroom. You probably will want to follow along as I sort of quickly explain the different things that are up with different kinds of reasoning. What we've been learning to do throughout this chapter when we talk about valid arguments and the basics of logic, and also what you did in geometry and any time you explained your steps in algebra, is what's called deductive reasoning. Deductive reasoning, you start with rules you know are true, and you use them and apply them to specific situations. We use that to prove things in math. It's also used in places like courtrooms. The whole legal system is based around deductive reasoning. Typically, though, deductive reasoning isn't what we use in everyday life. And that's because it's often hard to explain. However, deductive reasoning often doesn't have to be used either. And that's because in everyday life situations, there's other kinds of reasoning that are good enough to cover the things that we have to do. We're going to look at 4 different kinds of reasoning. The first of which is what's called inductive reasoning. Now, we did something very similar when we talked about the bad kinds of arguments, the invalid arguments we did earlier. Remember, improper induction was something that did not work as valid argument. It is, however, something that's used a lot in everyday life. The idea behind inductive reasoning is that you start by looking at specific examples, you observe patterns, and you see if you can use those patterns to determine general rules. We use this in everyday life all the time. In your book, they give an example of a student who pays attention in class and notices that every time the teacher says, "Put away your books and get out your pencils," there's going to be a pop quiz. That's the sort of thing that we really do use a lot. But there's more formal places inductive reasoning is used too. They give the example of Galileo using the observations he made by throwing balls off the Leaning Tower of Pisa to determine gravity and how its force works on Earth. Even things like Newton's laws of motion aren't things that can be proved. They're things that have been observed and then generalized. And inductive reasoning, you start with specific examples and you try and look at general patterns. The second kind of reasoning we're going to talk about is diagnostic reasoning. And diagnostic reasoning, one of the biggest examples of it is when a doctor makes a diagnosis. When you go to the doctor, you typically, unless you're a hypochondriac, don't say, "I have some disease." What you do instead is you say, "I have these symptoms." Like, COVID's all in the news lately, so you might say something like, "I have a cough, and I lost my sense of smell." And if you have symptoms like that, they're going to say, well, maybe you should get tested for COVID. Because what the doctor knows is that if you have COVID-19, you're likely to have those symptoms. So when you say you have those symptoms, the doctor is going to conclude that you might have that disease. If you think about it for a minute, that's converse error. They're going backwards, and logically you can't do that, but it really is the best the doctor can do under the circumstances. And this is used not just by doctors, but in lots of different situations. If you've got problems with your car and you go to a mechanic, Again, what you're likely to say is what's going wrong, not what the problem is. What the mechanic's going to do is look at those symptoms and see if they can figure out what's causing them. This also happens when, like, computer technicians are trying to figure out what's going wrong with the computer, and there's lots of other situations where the best we have to go on is what's happening, and we go back and we conclude what the cause is. So again, it's technically converse error, but in many real-life situations, it's the best we can do. The third of these is what's called concluding the inverse. Concluding the inverse literally is inverse error, but it's something that is very common in everyday life. And what it does in everyday life is it relies on an unstated if and only if, which people often imply when they just say if. For instance, in your book they give an example where somebody says, if it rains, we're not going to have a picnic. But somebody concludes that if it doesn't rain, you will have a picnic. And almost certainly that's right, because what the person that said it meant is the only way we're going to cancel is if it rains. So we'll cancel if and only if it rains. And that ends up being really, in most situations, absolutely accurate, because people mean if and only if, even though they've just said if. And finally, we're going to look at what's called probabilistic reasoning, which of course involves probability. The idea with probabilistic reasoning is there are lots of things that cannot be absolutely certain. But what we can do is to determine how likely different things are to occur, and then use our common sense to imply our action otherwise. And this can be very simple things, like if there's a high probability of rain, you decide you're going to wear a jacket. That would be probabilistic reasoning. They also have things like if somebody got 100 heads in a row flipping a coin, it's probably not an honest coin. And the whole idea is you use your common sense based on probabilities to determine what's actually going on. Now, one thing I will often do when I go through this section is to ask people to notice the number that's in there, which is 1 over 2 to the 100th power, and see if they could actually figure out how you would read that number aloud. You could actually see that the book I scanned this from, some student had actually written in commas trying to do that, and you might want to just pause for a second and see if you can figure out how to say that fraction. And it does end up being 1 out of 1,267 octillion, 651 septillion. And so you got a really small probability of this happening. Again, the whole idea of these methods of reasoning that aren't deductive reasoning is that you can't absolutely prove things with them, but in many situations they're good enough for what we need to do. There'll be a few problems in an assignment that I ask you to do with these, but when it gets to the test, typically all I do with this is ask you to come up with a couple of these other methods of reasoning and just really quickly explain what it's about. That's basically all you need to do with it. And so that's it. We're done with Chapter 1, and again, you'll have a brief assignment about this section. There will be some chapter review problems and a review worksheet to work on, and eventually we will get around to having the Chapter 1 test.